Okay, so today I am going to discuss another two problem from math physics came in this SIR net exam. So the first problem is from numerical techniques. So the question is this is the integral given that 0 to 1 2x divided by 1 plus x square is estimated by Simpson's one third rule with a step value of h is equal to 0.5. So you have to calculate what is I estimated minus I exact. So these are the options. So now look at the solution. So this is x is equal to 0, this is x is equal to 0.5, and this side this is x is equal to 1. And the limit of the integration is 0 to 1. So you have to calculate three values actually. This is 0, this is 0.5, and this is 1. So now this is our the integrand fx is equal to 2x divided by 1 plus x square. So initial value, that is yi, that is equal to f x is equal to 0. So what is the value of function at x is equal to 0? That is 2 into 0 by 1 plus 0 square is equal to 0. What is the final value? The final value gives f of x of 1, x is equal to 1. That is 2 into 1 divided by 1 plus 1 square, that is 1. And what is the intermediate value? There is only one intermediate value. The first value after x is equal to 0, that is y1. That is equal to 2 into zero point 0.5 divided by 1 plus zero point 0.5 square. That is equal to 4 by 5. So this is the estimated value of the integration that is given by the composite Simpson's rule. You can find this in numerical techniques in Google or in any Python book or any coding book. Okay, so this is the composite Simpson rule. That is h by 3. H is the step value, the initial and the final value plus 4 times the odd number of values, that is y1 y3. So the first step, the third step, the fifth step, the odd numbered case, and plus 2 times y2 plus y4, the even numbered step, that is uh, the second step, the fourth step, the sixth step, the even number steps. So we have only one value, that is y1, the first step. Other there is no other steps mentioned in the question because the step is 0 0.5 and limit is 0 to 1. So you have only one intermediate step between 0 to 1. So only y1 exists and no other values of y exists. So okay, so this is yi, that is 0. This is yi is equal to 1 plus 4 times. This is y1 is equal to 4 by 5, and there is no other terms present. So now we have to put h and do the calculation, that is equal to 0.7. Now what is I exact? I exact is equal to this integration, and you can simply do this by substituting 1 by x square is equal to p, then 2x dx is equal to dp. So it will be the integral of dp by p, that is log p. So the integral is log 1 plus x square 0 to 1. So that is equal to log 2, that is 0.707. So the estimated value minus the exact value will be 0.007. So for this question, the option 1 will be the correct option. Now this is the second question, differential equation, that is d2y dx2 minus y is equal to x sin x, and you have to find the general solution. So I use actually D operator method from the HK Das mathematical physics book. So for competitive exams, HK Das is the best book, I guess. And for your further knowledge, you can also read RFK or Relay Hobson. I mainly do Relay Hobson for further studies, but this is the best technique, I guess, for competitive exams. So for there is two part of this equation: the complementary function and the particular integral. So for the complementary function, you have to only consider the left hand side. That is d square minus 1 into y is equal to 0. So d is equal to plus minus 1. So you can write the complementary function as c e to the power plus 1 into x, that is e to the power x, plus c2 into e to the power minus 1 into x, that is minus x. So you have to put the values of d in e to the power some coefficient of x. The coefficient is actually d. So this is plus 1 and this is minus 1. For d is equal to plus 1 is e to the power x, and d is equal to minus 1 is e to the power minus x. So this is the complementary function, which is very simple for this case. Now we have to find the particular integral. So the particular integral part is equal to, look at the right hand side. The right hand side is x sin x. So this is the x sin x minus x sin x divided by d square minus 1 is your the complementary function operator part. So this is the operator part for complementary function, that is d square minus 1. Now to solve this kind of problem, you have to somehow convert this into e to the power x. So, okay, so you have direct formula for e to the power x, but not for sin x. So we know that sin x is the imaginary part of e to the power ix. So we can solve that. What is the particular integral for x e to the power ix divided by d square minus 1? And finally, we will take the imaginary part of this, and this will give us the right result. So to solve this, now x, this is x to e to the power x divided by d square minus 1. Now you can put this e to the power x outside this operation, e to the power x ix into x divided by what is this is d plus I n whole square minus 1. So if here is e to the power x, then it will be d plus a whole square minus 1. So the coefficient of e to x in the term e to the power x come in this d square term. So it will be become d plus I n whole square minus 1. So now you have e to the power ix into x by d square plus 2id minus 2. Now you can take minus 2 common, and do the you can do an infinite binomial expansion. So if you invert this, this will be 1 plus some term inverse. So 1 plus d square plus 2id by 2 plus half into d square plus 2id by 2 whole square, and so on. And you have x, you have to operate all these operators on x. Now remember that if you operate d square, d cube, and any higher order terms of d on x, that will surely become 0. But x is only linear, I mean it has power 1. So if you operate d square or d cube, then that will be surely be 0. So you can only operate linear term on d. So this is 1. So 1 into x will be x. When you operate d square, that will become 0. And when you operate 2id by 2, that is equal to I into d. So it will become I. D is d dx, so it will simply become I. And for this term, this will surely become 0, because these are higher order terms, all higher order terms. So now you have finally e to the power ix by minus 2 into x plus I. You can expand this, and you can take the imaginary part of this whole expression. So imaginary part of cos x plus I sin x into x plus I. So you can take the imaginary part of this. So your particular integral finally becomes minus half into x sin x plus cos x. So the total solution is the complementary function plus the particular integral part, that is c1 e to the power x plus c2 e to the power minus x minus half into x sin x plus cos x. So for this question, option 1 will be the correct option. This option 1 will be the correct option. So yeah, this is the technique to solve this kind of differential equation, and these are nicely given in the HK Das mathematical physics book. You can follow that. And thank you. If you have any suggestions or doubt, you can comment. Thank you.